Here we go. Very important for the next part. Properties. Easy marks if you follow along. Easy marks, in my opinion. Properties of quadrilaterals. And what are quadrilaterals? Four-sided polygons. So right now, everything, all the shapes we're going to talk about right now are four-sided, but they all have a specific name and they all have properties that make them unique. And I will do them in pairs. It's kind of like I present them as cousins because it's easier to remember. So the first one is parallelogram. Parallelogram. In short, I do this. Two lines like that, gram. Okay? Because that symbol stands for parallel. And then you draw a slanted rectangle. So it should be a little bit longer than it is, right? Wide. Like that. I'm going to zoom into the diagram for now. Okay, if you have the different, like I'm going to use red and blue to make it stick out. So there's the first property about a parallelogram is that this side right here, an arrowhead, is parallel to that side. Anybody know what parallel lines mean? If I said two lines are parallel, what do we know about them? Yeah, one. They're the same. I think what you're referring to maybe is that they're never going to meet. Yeah, it is basically a copy. They're copies of each other, but they will, like if I were to extend this to infinity, they would never meet, right? That's the main reason that we call them parallel, okay? So that's the symbol we use. And watch this. This line right here is parallel to that line right there. That's why it's called a parallelogram, because it's got parallel lines all over the place. I'm going to focus a little bit. Okay, another property about them is that this side, it measures the same as that side. And this side here measures the same thing as this side here. That's property number 2. And the third is that this angle right here is the same angle as this over here. Okay? And that this angle over here is the same thing, same measure as this one over here. So if I told you that it's a parallelogram, you would know those things are true. On page 190. Next, we have the rectangle. Rectangle is obviously something you should recognize. It's just like this, but except for what are all angles going to be equal to? They're all going to be 90 degrees, right? So that is a distinction between the two. So 4 times 90 is 360. In fact, the inside of any four-sided shape is always adds up to 360, no matter what it looks like. Okay. So next, I'm going to copy the same markings that I have up there. This side is parallel to that side. This side is parallel to that side. So they share that in common. I know that this side measures the same as that, and this side has the same length as this side. Sorry, that looks like one line, so let's make it two on either side. So what's the main difference between the two is that a rectangle has 90 degrees in every corner. Other than that, they're basically the same. Okay. And And here are some properties that are true for both of them. Opposite angles, I'm using that symbol for angles, right? Opposite angles are equal. I'm going to zoom out a little bit so that I need to write a little bit more. Opposite angles are equal / congruent. And this is the symbol we use for it, equal sign followed by like a wave, right? So that's the first property that we labeled. Two pairs of parallel sides. That's another property we labeled with the arrowheads. And then two pairs of congruent sides. Diagonals bisect. Anybody know what bisect means? Two waiters would say, hey, you want to bisect the tip? You want to split the tip? Yeah, so that's what it is, bisect. Cut in half. Okay, diagonals bisect. So, and for that, I would like a diagram all on its own. So just make a parallelogram again like this. And a rectangle like this. And diagonals are like this. You go from corner to corner. So you go across like this. The parallelogram has a long diagonal, this one right here, and a shorter diagonal. Okay. And let's make the same thing with the rectangle. Those are the diagonals that we're talking about. And they cut each other in half. So watch this. Because there's a long one here, this stretch from the corner to the middle would be the same as this stretch from the middle to the other corner. But the other diagonal, which is shorter, right, would differ from this one, but it would still be cut in half. So, right, the segments like here are cut in half. So those, you got to make sure you have a distinction made there. And then looking at this one, because both diagonals are the same, they're also cut in half, but the result is that all of those little cut, like the cut in half pieces, they all measure the same. So that's the difference when you're looking at that. So I will say this. There's one long and one short diagonal. And here, both are congruent. Okay. That's it for this one, for these cousins. Okay. So cut that, cut it there so that we can do the next two. We're gonna go almost, go ahead. We're gonna go almost right till the end with this, okay? So I'm gonna give you all of this, talk about it, and then on Monday we can continue. Are we good? Okay. I'm gonna go here and let's do, we're gonna talk about the rhombus. Rhombus, right? It's a slanted square, guys. So just make a square and it's just leaning over, right? Like one of those sheds when you go down the highway, right? Those old barns. Okay. And here are my markings again. I'm going to zoom into the diagram for now. Okay. So this side is parallel to that side. Nothing has changed there. This side is parallel to that side. Nothing has changed there. Property number 1. Property number 2 is that this side measures the same as that, and that this side measures the same as that. You got to make sure that if things are measuring different, that, oh, sorry guys. You know what's wrong with that, right? I just made the mistake that I was going to tell you not to make. Can you just make that just a 1 mark? Because all 4 sides are the same. Okay, so in that case, you go 1, 1, 1, 1 everywhere. Okay, my bad. And then this angle here is going to measure the same as that angle across from it, just like the parallelogram. This one right here will measure the same thing as this one over here. And then we're going to do the square, which is the cousin of the rhombus. So let's just draw a square. And obviously, you would know that a square just has all 90s, that this side is parallel to that side, and this side is parallel to that. I know it's obvious sometimes, but I need those markings there if I ask you to identify. And you can say that this side and this side, all 4 sides measure the same. And now we can write down the properties. Right here, all sides are congruent. Okay, and then opposite angles are congruent. Two pairs of parallel sides I will say that diagonals bisect and diagonals are, this is new, perpendicular. What does perpendicular mean? They meet at 90. Meet at 90 degrees. Sorry, you can't see that, can you? Okay. And so we're going to make 2 diagrams here again. So draw a rhombus real quick. And a square. And all we're going to focus on is the diagonals here. Draw the diagonals just like that. And then watch this. It's very important that you know that these meet at a 90 here. If you know that it's a square or a rhombus, they meet at a 90. Okay, so that's what I mean there. And for a square, all 4 of these would be the same. For a rhombus, this would be the same as that, and this would be the same as that. So the diagonals bisect each other, and they meet at a 90. Can I just say something here? That the first 2, there is no 90 here. If you put a 90 at the first, like the parallelogram and the rectangle, it would be wrong. Okay? It is only with the square and the rhombus where that is the case. We're done with those 2. Okay? The next one I'm just going to call trapezoids like this, and I will talk about the isosceles trapezoid. And so we're going to split that this way, and this is a right trapezoid. Okay. Isosceles trapezoid and the right trapezoid. The isosceles trapezoid looks like this. It's basically a triangle cut off, like the top is cut off. Okay. We know that these two are parallel. We know that isosceles says that two sides are the same, right? So this one is the same as that. In terms of length, they are the same. We also know, if it's an isosceles, that this angle is going to be exactly the same as this, and that this angle is exactly the same as this. Okay. I'm going to write a little bit in just a little while. So the right trapezoid okay. Let me redo this. This doesn't look very good. Okay, make it like that. The right trapezoid has two 90-degree angles here. And it has these lines being parallel as well. And that's about it. That's all it has to be unique. It is the 90 degrees that make it unique. Okay. So under the isosceles, you'll say this. One pair of parallel sides, two pairs of congruent angles, right? It's got the bottom two are congruent and the top two are congruent. So two pairs of congruent angles and one pair of congruent sides. Those are the properties that you can label on that isosceles trapezoid. So if I ask you to label it, the labels need to show up there. But I might also ask you questions in terms of a word problem. So you got to be able to identify it. This one has one pair of parallel sides, one pair of right angles. One pair of parallel sides, one pair of right angles. And now I'm going to give you a property that's going to make your life a lot easier when you're working with these, because you're going to do the same thing as triangles. You're going to try to figure out to get information out of it. They're going to give you partial information. You're going to fill it in. So grab, if you have a red pen or something, these two angles here always add up to 180 degrees. And you can tell 90 and 90 obviously is 180. But so do these two angles. So make a line going out of this and going out of that. Those would also measure 180. So if you add them up, they would add up to 180. Meaning, if you know one of them, if this is 100, then this would be 80, right? Like you can tell right away knowing this fact. So for every single diagram, we're quickly going to go up and just do that for every single one of these. But I'm just going to stick with one side, otherwise it gets too crowded. 180, 180 there. Go up to the square. Obviously, we know it's 180. Rhombus. Do the same thing. and you go up to parallelogram and the rectangle, you do the same thing. This is, to me, in my opinion, the most helpful property of all, is that they add up to 180. Oops, sorry. So 180 is only this way, not sideways, okay? Some of them do, but not always. Next page. It's another blank page. You thought we were done, right? Almost. I promise we'll be done in probably 5 to 7 minutes. Last one is the kite. There's no such thing as diamond, right? Maybe you write that to yourself next to it. There are no diamonds, okay? Because sometimes I'm like, identify this shape. It's a diamond on a test. I'm like, we never talked about diamonds, right? But it looks like a diamond, okay? So here we go. I want you to think of two isosceles triangles stacked. That's what I want you to think of when you see this shape. So I will guide you through it. Draw a triangle. Make it isosceles. So this side is going to be the same as that side. And the bottom, you just use a dashed line to connect. Make one of those. Got it? The bottom will be longer. So we're going to make an isosceles triangle, where we're going to make it a little bit longer than the top, where we tell you that this side is the same as that one. So this is an isosceles, and the top is an isosceles. Make a dashed line going from the top for the diagonal going up and down. Make a dashed line there. And you can tell that these meet at a 90. So that is actually true. Also, one of the diagonals, only one of them, which is the shorter one, is bisected. It's cut in half at this point. It's cut in half. So how many right triangles do you have in here? 1, 2, 3, 4, right? And you also have two isosceles triangles like this. So let's talk about the properties. Two pairs of congruent sides, shorter or short diagonal, bisected, diagonals are, what does this symbol mean? Bonus question. Perpendicular, right? Which means they meet at a 90. And last but not least, one pair of congruent angles. And this is where I'm going to give you a diagram, a separate one. What that means is just draw a kite to the best of your ability. And these two angles, only these two are the same. Not the top and bottom, only the one that's connected by the shorter diagonal. And remember, sum of a rectangle is always equal to 360 degrees. The interior angles of any four-sided shape always amount to 360, and that comes in handy quite often. Okay. This is the summary of a very long document that I used to make my students read, and they went crazy. You're probably going crazy already as is. So just imagine just a long document where you have to get all of this information out. So I kind of summarize it like this with diagrams. And I can guarantee you that a test will have a bunch of questions where it will ask you, draw me a kite and label 2 things about it, or 3 things, or whatever. And so, can I just do one? I want to do one example before we go, because I find that this was all dry and boring, and I get it. So let's just do one example before we go. It's not going to take long. Sketch a parallelogram, label 2 properties. Just write that down, and I will guide you through it real quick. We're going to make 3 versions of this. So draw 1 parallelogram, another one. So I'm going to assume that you're 3 different students that would have answered this in 3 different ways. So let's say student number 1 comes along, and that student says, well, I know that this is parallel to that, and this is parallel to that. 1 mark. What's another property about a parallelogram? Well, this side is the same length as that side. This one is the same length as this side. Boom, 2 out of 2. You nailed it, right? Student number 2 comes along. That student looks at the study sheet, is like, okay, this one is the same as that one, and this one is the same as that one. 1 mark. You're telling me that there's 2 pairs of opposite angles that are congruent. And that student wants to get the 2nd mark and says this one is the same as this is the same as this. 2 out of 2. You nailed it. Next student comes along. This one wants to show off, right? So it's going to be like, okay, right, and says that this cuts that one, this one cuts that one. 1 mark. What else can you do? You can talk about parallel lines, but this is what I'm going to do this on purpose. You want to now tell me that these are the same length. Can you use just 1 mark like that? Is that correct? No, because you already used that, and we don't know if these are the same. So how many do you have to use? You have to use 3, right? And 3, because all of these are different, right? You're making notion that this one is the same as that one. And 1, 2, 3, 4. 1, 2, 3, 4. So yeah, not ideal, but and there are more versions. You could have talked about parallel lines, right? So I just want you to know there isn't just one way of answering these. I will stop there.